Hi and welcome to this tutorial. We want to look at data structures in R. I like considering data structures as containers that we use to store our values or objects. And those containers have specific purposes and functionality. And once we understand how to work with them, it will make our analysis very easy. We'll start with the first one, which is a vector. A vector is usually one-dimensional, which means it's like n by 1 or 1 by n, depending on how you want to use it. Also, it usually is homogeneous in that it can only store one type of variable for every element in that vector. Here we are in line 59. We have created a vector called vec. We can be able to know how many values are in there just by simply using the function length. If you want to look at the entire value, all the values that is, you can see I've just run vec and it has given me the values 10, 20, 30, and 40. I can be able to subset. And when you want to subset, we specify the position of the value we are interested in. You can either do the position or you can subset by using some logical functions to subset if you don't want just subset one at a time. In this case, the value in position 2 is 20. When you do scalar multiplication on a vector, it is applied on all the vectors. Another data structure is the matrix. A matrix is like a continuation of a vector. The difference is that it is usually two-dimensional. In this case here, we're going to create a matrix. First, we are going to create a vector that has values 1 up to 9. Then, when you're creating the matrix, it is usually nice you want to be, in this case, you want to have a vector or a matrix that is designed in a way that it can be able to absorb all the values. In this case, we're going to do a 3 by 3 matrix. So you have specified you want 3 rows and 3 columns. You don't need to put 3 rows and 3 columns. You just need one of them, then it will automatically calculate the other one. Also, the default is usually to put the values by column. So if you don't want them to be put by column, but rather by row, you have to specify that in this argument by row is true. So in this case, when we run, you can see we have values 1, 2, 3, 4, 5, 6, 7, 8, 9. If we change this to make it around 7 and we run, you'll see what happens. First, we got a warning message because our matrix is supposed to be a 3 by 3 that should have a total of 9 values. So once we exhausted the 7 values, it had to restart from the beginning of our vector. When we look at the dimensions, it gives us we said it's 2 dimensions, so it gives us the length of in each dimension. And also you can get the sums for each row. In this case, you can see 1, 2, and 3 sum to 6, 4, 5, and 6 sum to 15, 7, 8, 9 sum to 24. Other than that, we have data frames. Now, data frames are a bit heterogeneous in that each column can have a different type of data. In our case here, we have created a data frame which has 3 rows, 3 columns. The first one is called the name. So this function in line 79, str, gives us the structure. So it tells us the number of rows or observations and the number of columns or variables. So the first row is called the name. It has character values. The second column is age. It has numeric values, and the third column is grade, and it has character values. You can be able to reference all the values in one column using the $sign. So in this case, students $name gives us all the values in that column. If you want to view, you can be able to even have a look at the spreadsheet kind of the data by using view with capital V. And also you can be able to subset. Remember, it is two-dimensional. You can subset the first row and the column called age. So when we do that, we get that the age of the person in the first row is 20. As you can see, even in this view, the first person has the value 20. Right. We also have a data structure called list, which is kind of nice because it can hold all the other types of data. So when I run lists, each list has been given a name. So when we look at it, you can see the first bit has a vector, the second one is a vector, the third one is a matrix. And they've been given names. The first one have been given the name called numbers, second one the name called words, the third one the name called matrix. If there are no names, even with the names, you can always select an element, one item in the list using double brackets. Like for example, if I want only numbers, I can use the double brackets and I can get the 1, 2, 3. Or if I want, if not, I can just use the name that has been given. Like when I want words, I select, it has subset for me all the values inside the list of words. However, if I want a specific value within that list, like in this case, I want to extract this value 2 under numbers, then I have to subset it twice. First, I subset the list, then how to subset the value based on the type of data frame that is there. So when I run that one, I get that I've subset the 2, and the 2 that I've subset is this one. So if I wanted to get this 4 here, then I will say I want the list number 3, and because that is a matrix, I will put the 2 dimensions, the position, and that will give me the value 4. Now, lists are usually very important because you are always dealing with messy data, so it can be used to collect a variety of data from whichever source, and somebody can be able to work with it. Earlier on, I mentioned concerning factors. So if I'm to create a vector like this, you can see this is a vector that has red, blue, red, green. It has 4 elements, but once I coerce it as a factor, it has the values, but then it gets levels, only 3 levels. That is blue, green, and red. So um, factors are usually nice when we are dealing with categorical variables. And notice also that these were organized in ascending order, alphabetically. So in the event that you're working with ordinal data, you might want to order them in the way you want, and something we're going to learn in the later tutorial. The last command here, table, gives us the counts for each of the categories. You can see blue, green, and red. We had 2 counts for red. Thank you.